transformers.
Hi and hello. Today we are going to discuss about the electrical machines. We have a transformer, motors, generators, but we are going to discuss about the transformer today. A transformer is a machine which converts power from one part of the circuit to another circuit. Like it transforms power from one part of the circuit to another circuit without changing the frequency. So this is the basic definition of a transformer. Next thing, we are going to see the working of the transformer. This is a transformer. We have two types of transformers, that is step down transformer and step up transformer. In step up transformer, the primary windings are very less than secondary windings, so the voltage at the secondary winding will be greater when comparing with the primary winding. But whereas the step down transformer, for a primary winding the windings are higher, but in the secondary coils the windings are much lower when compared to the primary winding, so the voltage at the secondary will be much lesser than the primary winding. So this is a step down transformer. We have two types of transformer, but this is a step down transformer which will reduce the voltage. The voltage obtained at the secondary winding will be very much less than the primary winding. So I will show how is it working. Now I am switching on the power supply. So the power is switched on. This is the primary winding and this is the secondary winding. So the voltage obtained at the secondary winding will be lesser than the primary winding, since it is a step down transformer. This is the step down transformer. So I am going to measure the voltage at the secondary winding. So I am getting around 7.6 voltage, but the voltage which I have given in the secondary side is 220 volt, but the voltage I am getting at the secondary winding is 7.6. This is because of the mutual induction. Actually the principle of the transformer is nothing but the mutual induction, but this is based on electromagnetic induction, Faraday's electromagnetic induction. So mutual induction is the subcategory for the electromagnetic induction. So I am going to teach how to test a transformer, how to know the primary winding and the secondary winding. So I am going to teach about the diode test. This diode test is used to determine the secondary windings and primary windings. You may have doubt how to find whether it is secondary winding or primary winding. If I am rotating it like this, you may be confused whether it is the secondary winding or primary winding. So using a multimeter, I will teach you how to do the diode test. So keep the range in diode test, micrometer, and any terminal. You can connect to the any terminals, whether it is a primary or secondary. When you are connecting, if you are getting the larger values like 1562, this is the resistance inside the transformer. So if you are finding this value, it is understood that this is the primary winding. If it is a secondary winding, if you are placing your terminals here, you would get a beep sound. So by listening the beep sound, you can know that it is a secondary winding. So, and the next one is I am going to teach about the two-port networks. That is Vi is equal to Y. Sorry, pass one.
Rolling.
So next we are going to see about the two-port network. This is the two-port network. Two-port network is nothing but the analysis of impedance, admittance, G parameters, H parameters, and ABCD parameters within the two-port network. So in the two-port network, we are going to see about the impedance and admittance. This is the equation for impedance. Impedance is nothing but in an AC voltage, the resistance applied to the current flow is impedance, and the admittance is inversely proportional to the impedance, like conductivity inversely proportional to resistivity. So this is the equations for impedance and admittance. And the next thing we are going to see about the working of transformer, a theoretical transformer. So this is a theoretical transformer. Here we have a primary winding supplied by alternating current, and another one secondary winding. So here it is connected to a multimeter. So here we have set in the voltage range. We have set. So the alternating current which is supplied at the primary winding, because of the mutual induction, the varying EMF will produce current in the primary coil, and the alternating EMF will produce current in the secondary coil. So this is the working of transformer. The main reason for the working of transformer is nothing but the mutual induction. Like in a short form, if you are applying an alternating EMF to a coil, it produces a magnetic field. So this alternating EMF will produce a magnetic field. Due to this magnetic field, a current would be produced at the secondary coil. So this is the principle of electromagnetic induction. So just we have seen the working of transformer theoretically, but this transformer is impossible in practically. It is possible only in theoretical part, because there is no metal, there is no core in between these two coils. In a practical transformer we have core in which it provides low reactance path. So the conductivity between primary and secondary coils would be more, and the mutual induction would be increased. So the EMF produced at the secondary coil would be greater. When you are placing a coil primary and the secondary, if they are not closer, the EMF produced in the secondary coil would be very less. So this is the principle of the transformer.
This is me.
Thank you.